Hi, so a quick follow-up. So we ended the last video by talking about the tidy function, which extracts the model table from your model, and by manually computing the lower and upper confidence intervals. Here's the thing. Um, you'll notice that it says 1.96 for this right here, that we are multiplying the standard error by that so that we can subtract it from the beta coefficient to get the lower confidence interval. Same thing for the upper. This value, 1.96, is almost always that if your sample size is really large. There's a process, a couple formulas that will change this ever so slightly in the event that you have a small sample size. In our case, we kind of do. We have only 100 observations. That's like a small-ish sample. So although we very quickly and easily calculate the confidence interval for this, this would be a little overconfident, you could say, given our sample size. The good news is modern Dive's get regression table function can do this all inside very quickly, and it will take care of the sample size number crunching. So, for example, you can see that the lower confidence interval from get regression table for intercept is a little bit lower than the lower confidence interval that we made ourselves. Why is that the case? I would think of it this way. You can use this shortcut if you have a really large sample size. 1,000 is usually good. But if you want to be really, really accurate, which of course we do, I would advise using things like get regression table to get those confidence intervals. They work really well, and you can see it right here. What it actually did was it went and figured out that because we have a lower sample size, the 95% confidence interval is actually going to be stretched out a little bit. And so instead of 1.96, they actually multiplied theirs by 1.98. That's going to vary for every single data set depending on your sample size. So this is one of the really good reasons why you should use get regression table instead. So moving on, we can use get regression table to get our lower confidence intervals and upper confidence intervals. And we can visualize the range where 95% confident that the beta coefficient lies in. For example, like this. I'm going to let you guys read the application yourself, but let's just talk over section 7 real quick. So we can make this beautiful plot, which plots the beta coefficient and the confidence interval on either side for each variable in the model. And you can edit this as you like. For instance, if you wanted only statistically significant variables, you could filter so that the p-value had to be less than 0.05 to be in the model, to be in the visualization. You'll also notice another cool thing about this. The intercept crosses 0. That means that we're 95% confident that the effect of the intercept is either positive or negative. That means we don't really know much about it. Any variable that crosses the intercept with its confidence interval tends to be statistically insignificant. We're not confident about its effect. How would we make this pretty chart? Well, up here, we would use get regression table to get the right confidence intervals given our sample size. And then we would map them to aesthetics. So we would say, make the variable name, the term, go in the x-axis, make the estimate, the beta and alpha coefficients, go on the y-axis, and make the y min which is kind of like the lowest value of y. The lower confidence interval, make the y max, the upper confidence interval, and we can draw a ribbon using geom ribbon between the y min and y max. We can also draw over top of it a geom point, which is, it doesn't care about y min or y max, it just cares about y. So for example, this dot is geom point, and this line is geom ribbon. Last, we can also use geom h line, which says, hey, find where the y-intercept equals 0 and make a line. You'll notice, though, that this is a little funny. I just said that the term, the variable name, was going to be on the x-axis, but we see it's on the y-axis. And the beta, which should be on the y-axis, is on the x-axis. That's because I use coordinate flip. I find that these charts make more sense when they're laid out this way than when they're flipped. You can do it either way, and it's kind of a visual choice. So coordinate flip flips the x and y axes very conveniently. Okay, that's all we got. This is how you visualize 95% confidence intervals. Please feel free to shoot me an email if you have any questions about how to do this or want to apply it. And please, please, please use get regression table when you're getting your upper and lower confidence intervals. It is really convenient, and I highly recommend it compared to doing it manually yourself. All right, thanks for tuning in. Have a good one.